triangle? Go for it.
The two legs, the longest side is the opposite and the shortest side is adjacent.
Okay. So the side across from theta, or your reference angle, is your opposite. Okay? The side across from 90 is always your hypotenuse, which leaves the other leg that makes the right angle your adjacent. So this one's your adjacent. What is the sine of theta, or my reference angle? What is it? Opposite over hypotenuse. How about cosine? Adjacent over hypotenuse. And finally, tangent of theta. Opposite over adjacent. We used a little mnemonic to help us memorize this. So, toa. Sine is opposite of hypotenuse, and so on. Okay? This is helpful when you're doing the practice problems to really quickly memorize those rules. You got to find the sine, cosine, and tangent for this triangle down here. For sine of theta, what was the fraction you got? 9 over what?
41.
9 over 41. Opposite, hypotenuse, adjacent. How about the cosine of theta? 40 over 41. And finally, tangent. What's the last one? 9 over 40. Can I simplify any of these fractions? I cannot. No. I cannot simplify. If you could reduce, you would reduce. This is what we did Friday. Okay? This is what we started. Today we're going to continue using these things. I would keep this warm-up out so you can take a look at it as we work through lesson 9.5. Let's look at 9. What information do we need to solve a triangle? Okay? Can we find the key to unlocking any right triangle? So we're going to explore this today, and we're going to start with number 1. It says, given that triangle UVW is what to triangle ABC? What does that symbol mean? No, not congruent. Similar, right? We just did this last unit. So we're going to start by saying they're similar, and you need to find the hypotenuse for the second triangle, okay? So I want you to recall, what did we do last unit? You and your partner find the hypotenuse for this triangle using similar figures. This is review. Give it a try. Go. Set up the corresponding sides, and then we cross multiply. We cross multiply. We should get 6x equals 180. We're going to divide both sides by 6. We should get that hypotenuse is 30. Okay? Number 2, how does having a similar triangle help you determine the missing side? How did that help us? We could set up an equation. An equation and solve. Okay, now they want us to find the sine of W and the sine of C. Give that a try. The sine of W and the sine of C. I would start by deciding which sides are your opposite and hypotenuse. Any questions on how I found the sine of C or the sine of W? Just identify your opposite, identify your hypotenuse, and simplify the fraction. The sine of W and the sine of C, they both simplify to 1/3. That's interesting. Why did they both simplify to 1/3? Because they're similar triangles. Number 4, let's look at a new triangle shown at the right. If sine of theta equals 2/5, find the missing sides. How are you going to do that? Again, use this idea of similar triangles. Try number 4 right now with your partner. How are you going to find the missing side? Use this idea of similar triangles. Give it a try. Of 2/5, opposite, hypotenuse. Right now, I know that this is my opposite. I do not know my hypotenuse. I'm just going to leave it as x. So I'm going to set up a similar figures ratio and cross multiply. Some of you told me you just saw, right, that 2 and 14 are corresponding sides, and it did what? Times by 7, so then you did 5 times 7, and you got it as 35. Okay, either way is fine. Okay, that's a great way to solve it. So it should have been 35. This is 35. Is theta equal to the measure of angle W? So back up here to sine of W. The sine of W simplified to equal 1/3. Is this the same? The sine of theta is 14/35. Turn and talk with your partner. Are these things the same? How can you prove it? Are they the same? What does 14/35 simplify to be? What do we think? 14/35? What's that fraction in your calculator? 0.4? Or what? Or 2/5, which is not the same as 1/3. So no, they're not equal because those ratios are not the same. Do we see why those triangles are not similar? Because the angles will not be the same. The sides, the corresponding sides, are not proportional. Number 5, how does knowing the sine ratio help you determine the missing sides of the triangle? How could I figure out this side now? What? Yes, what equation will we set up? What is it? Yeah. Let's do that right now. Let's find the other side. Let's find the other side of this triangle. Sine help us got there because we can figure out two sides, and now we use Pythagorean theorem to figure out the rest. Let's do that. Sine got us two sides. Don't forget, Pythagorean theorem is part of this unit. Okay, we did it last semester, but you're also going to be using it on this test too. Number 6. Can you figure out the missing side lengths of this triangle? Explain. Take a look at this right now. Can you figure out the missing side lengths with the information given? Try it right now with your partner. Number 6. Can you figure it out? You've got 40. What is this side? This would be the opposite. This would be the hypotenuse. So this would be adjacent, right? You could set up a couple different equations. You could say the cosine of 40 equals 5 over unknown, right? Is there another equation you could set up? Oops, I flipped those, didn't I? You could use tangent. Tangent of 40 equals unknown over 5. Does that help us get any closer? Was there anything on Friday that I showed you that you could use in your calculator? Could I do the cosine of 40 in my calculator or the tangent of 40 in my calculator?
Oh, it's
Would that help me? Okay. Let's go to the quick notes and we'll do a few examples together. You will be using your calculators now. We'll do the check for understanding to get started. We need to remember from Friday that you can use your calculator. You can use your calculator to find or look up the ratios that go with any triangle. Remember, there's a sine and a cosine and a tangent button on your calculator. Don't forget that. They're there. We'll do some examples in a second. Basically, what we had set up before is if I know an angle, like we did in that last example, and I knew a side, this will give me a number in the calculator, right? And then I can cross multiply, right? So let's do the cosine of 40 in our calculators. What's the cosine of 40? 0.76 cosine of 40. So I can replace this now with 0.766. How would I solve for x? Over 1? Yeah. I could put that over 1 and then cross multiply. I could cross multiply. So in your calculator, you can do 0.766 times 5. About 3.83. So I can use this information to solve for an unknown side. Okay? How could you find the other side after that? Pythag theorem, right? If I know this is 40, this is 5, and we just solved for the other side, which was what side? This was A, this was H. We can use Pythag theorem now to solve for our other side. So we have all the tools now to solve for missing pieces on our triangles. Okay? Any questions about finding missing sides? Yes?
Isn't that 3.8?
You've got 31. X is your opposite. This is your hypotenuse, so 8 is your adjacent. So what trig ratio are you using? What? Opposite and adjacent. Opposite and adjacent. Tangent. So I'm going to say the tangent of 31 degrees equals x over 8. What am I going to do to get x? Tangent of 31 times 8. Give it a try now. And then try B. For 2, part B, what trig ratio are you going to set up? What trig ratio for 2, part B? Got 6 and x, and the angle is 55. Opposite. Hypotenuse.
He doesn't work out.
Okay, we'll check it. When x is in the bottom of the fraction, what I would do is multiply both sides by x first. That would reduce those. Then I've got x times the sine of 55 equals 6. How do I get x alone? Divide by the sine of 55. So be careful. This one's set up a little bit different algebraically. So in your calculator, you can do the 6 divided by what the sine of 55 is. So be careful with this one. Algebra. If you're confused, it all comes back to algebra. For 3, you should start with this. 28 is my reference angle. Opposite hypotenuse. Unknown over x equals the sine of 28. You're going to times both sides. Or put this over 1. Whatever you want to do. I'm going to times both sides by 13. 13 times the sine of 28 will get me this side. How are we going to solve for the adjacent in this triangle? Pythag theorem. How are you going to solve for this unknown angle? The angles in a triangle add up to what?
180.
Right. Do 180 minus 28 minus 90. Hey, that angle is 62. So we're going to start asking you to solve for all the missing information.